Module 6, Radical Functions and Equations. The first topic we're going to discuss is the graphs of radical functions and then the transformations that exist as well. The first objective is we're going to graph the parent radical functions. We'll take a look at what those look like, and then within this video I'm also going to move on to objective 2, which is transformations based off these radical functions. All right? So to begin, there are two radical functions that we care about in Module 6. Part A is the square root of x, and part B is the cubed root of x. That's how you say both of those. Square root meaning that this is square, or you're taking the second root of x for part A, and then the third root of x for part B. In order to discover what these look like, I'm going to use a table of points. I'm going to have inputs, or my x values, and they're going to give me my outputs, or my y values. I'm going to write the square root of x down here just for reference, because every time I input one of these x values, what I'm really doing is replacing the x underneath the radical to get a new value. And because it's the square root, I'm going to use perfect squares for my inputs. All right? So the 0, you can always use 0 because the output will always be 0 for the parent function. First perfect square then is 1, then 4 is the next one, and 9 is the next one after that. Perfect square meaning if I take the square root of that number, it'll spit out a whole number, an even number. Now, the square root of 1 is 1. If I replace this x with 1, I will get the square root of 1 to equal 1. The square root of 4 is 2, and the square root of 9 is 3. So I have my table of points. I will plot those. Sorry, square root of 0 is 0. So the first, it begins at the origin. Every parent function begins at the origin. Then I go over to 1, up to 1. Over to 4, up to 2. And over to 9, up to 3. If I connect the dots, that is the square root of x. That is a radical function. If you notice, if I were to draw the reflection of all those points, over to 1, down to 1, over to 1, over to 4, down to 2, over to 9, down to 3, hopefully you can recognize that this looks like the quadratic function x squared on its side. And we're going to talk about this in a later module, or I'm sorry, not in a later module, a later objective, but the square root of x and x squared are inverses of each other, all right? Meaning they're reciprocals about the line y equals x. So just keep that in mind. The square root of x and x squared are inverses of each other, and that's going to come into play later on in this module. But all we really care about for now is the graph in blue. The graph in blue is the square root of x. That is the parent function we care about. Now, moving on to the cube root. The first input I'm going to use is 0, and for my reference point, I'll write the cube root of x. And the cube root of 0 is 0. Now, in this case, I can use negative inputs for the cube root of a function, because the cube root of a negative will give me a negative answer, because the cube is a 3, and that's an odd root. Same thing as an odd power. Remember, you can't take the square root of a negative, so all of my inputs had to be positive here. But I can take the cube root of a negative because of the odd root. So I'm going to start with the positive 1. The cube root of 1 is 1. And then I'm going to jump to the next perfect cube. In this case, it's 8. A number times itself 3 times, which would give me 8, would be 2. 8 cubed is 2. So if I were to do that math quick, the cube root of 8 is 2. And technically 2 cubed leads to 2 times 2 times 2 is 8. That's that math, all right? And finally, the next perfect cube that we care about, well, actually, that's as big as we're going to go. Now, I can go in the negative direction as well, though. So negative 1 will spit out the cube root of negative 1 is negative 1. And then negative 8, cube root of negative 8 is negative 2. So we can go in the negative direction in this case. So if I plot this, I go over 1, up 1, over 8, up 2. Then I go in the negative direction. Over to negative 1, down to negative 1, and over to negative 8, down to negative 2. And I'm going to connect those dots. And there you go. That's the parent function for the cube root of x. And hopefully you can guess it by now. The inverse of the parent function of cube root of x is x cubed. And we're going to talk about inverse functions later on within this module. So there are the parent functions, what I drew in blue. The cube root of x right here, and the square root of x over here. Alright? So keep those in mind as we're working on transformations, because we're moving on to transformations of radical functions. I will do this in the next video.